Hello, sir. Is my screen visible?
Yes, sir.
Okay, okay, great, great. Let me open code. Okay, so we'll start this session. So before starting this session, let me introduce myself to you all guys. Hello, everyone. I'm Swarit Mahalsekar. I'm a biomedical engineer. I'm a full-time content creator, and I make content and courses related to electronics. So till now, I have hosted around 10 plus courses on various platforms like Udemy, Skill Success, Tutorials Point, Easy Extra, and there are many other platforms as well. A few of my courses which are listed on Udemy, they are also selected on Udemy Business. Meaning is that those particular courses would be accessed by the employees of some renowned companies like TCS, Pinterest, Adidas, Volkswagen, etc. And till now, I had tutored more than 2.5 to around 3k plus students as well. And my YouTube channel has completed around 1k plus subscribers within 1 or 2 years. So this was a short introduction about myself. And apart from that, I teach on various other platforms as well. Okay. So now we'll start with this session. But before that, I know that since you are in third year, right? So you all guys might have done at least 2 to 3 different projects, right? So I know your approach will be, somewhat equivalent to mine only when I was in, second and third year. Like you might have, just a search certain project, right? And then you might have just connected those hardware components, or you might have downloaded the code from the internet, and that's it, right? You never try to do something on your own, right? Never try to understand on your own, right? So basically what I want to explain in this particular session is, obviously we are going to understand this particular project, but with that we are also going to look upon the approach, that how exactly we are going to process further in this particular project. Okay, is that fine? Can someone acknowledge? Hello?
Yes, sir.
Okay, okay, great. Okay, so let's start with this session. So our agenda is to learn this particular project, that is heartbeat monitoring system using 8051 controller. Okay, so first thing first, whenever you do any sort of project, the very first thing that you should focus upon is the block diagram. Okay, because block diagram actually gives you, or it helps us to understand that how we should process further. So starting with the very first point, that is a sensor. Okay, sensor is connected, like whatever the output that our sensor gives, it is connected to the microcontroller, and then whatever the microcontroller that is like whatever the output that this particular microcontroller will provide, that will be given to the LCD. Now let me just show it to you. See, this particular sensor, this particular sensor will be present somewhere near to your skin or near to your body, right? Because it needs to catch certain data. It needs to catch certain data. So what it will do, it will catch that particular data, and it will provide certain signal to this particular microcontroller, that is 8051 microcontroller. We are specifically focusing upon the 8051 microcontroller, right? Now it is the task of this particular microcontroller to convert this particular data into the readable format. What does that mean? Let me write over here. We need to convert this particular data into the, or this particular signal into the readable format. So this is my signal, okay, which we are getting from the sensor. Okay, so this is the actual task of the controller. And when I say I want it in the readable format, that means obviously we are monitoring the heartbeat. So I just want to know within a minute, how many beats or how many heartbeats are occurring. It can be 60, it can be 70, it can be 100. It depends on person to person. So basically, if you look over here, let me select this color, and yeah, let me show it over here. So might be, some person you might see heartbeat as around 70. In some person you might get heartbeat or beats per minute as 60. In some you might get 100, right? So this particular data we can read it, right? But what exactly this controller is doing, it is actually converting this particular data. So basically it is processing this particular data. Okay, I hope you are able to understand this, guys. Okay, can anyone acknowledge? Hello?
Yes, yes, sir.
Okay, 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 great.
See, we are sitting in a class
Okay, okay.
and meeting is played on a screen.
Okay, okay.
How?
So, sir, if anyone gets any sort of doubt, I'll, let them ask. I'll clear that as well. Just ask them if anyone has any sort of doubts up till here.
For doubt session, we'll log in from the mobile phone and we will ask you the doubt. Maybe in
Okay,
some
okay,
time.
no. Okay, okay, fine, fine. That's great. Okay. So now I will proceed further. Okay. So now we'll focus on each and every block that is present over here. So now we'll first focus upon the sensor. Okay. So let me proceed further. Okay. So now we'll focus upon the working of sensor. But before that, I would like to ask you this particular question that, what sensor we are going to use. Okay. I will just give you a hint that it should be a non-invasive. It should be a non-invasive. I believe that you all guys know the meaning of non-invasive sensor or non-invasive thing, right? Sir, do we have electronic guys over here? Electronics के बंदे हैं क्या sir?
Mostly biomed actually biomed.
Okay, okay. So I'll just explain this particular term. Non-invasive means we are not cutting a skin. We are not cutting our body part. Okay. This is the meaning of non-invasive. Non-invasive. So what does that means? This particular sensor would be placed above your skin surface. Okay. I hope you all guys got this particular concept. So now I'll request someone to give this particular answer. According to you, which particular sensors would be used, like whether it is a resistive sensor, capacitive sensor, pressure sensor, or any other sensor? Can someone give answer this particular answer to Harish sir? Just try to think in your mind which particular sensor should we use, provided it should be non-invasive sensor. Any random guesses will also help. No issues.
Sorry, I have given them the access. They'll
Okay,
post the questions on chat box
okay, okay, no issues.
or
Okay, I'll
question or
just.
answer any doubt. Okay.
Okay, 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 okay. Hello. Can someone give this particular answer that which particular sensor should we use for this particular project? Any rough idea, basic idea that will also help. ECG, EMG, no, it should be non-invasive. I know ECG is also non-invasive. That is also a good idea, but we want it to be cost effective. Any random guess? Just tell me the type of sensor, like what type of sensor it can be. Whether it can be a pressure, humidity, temperature sensor, resistive sensor, or capacitive. Flex sensor, no, no. But wait, I will give you the correct answer. But let me go on to the blackboard. Okay. So the sensor that we are actually going to use, it is an optical sensor. So let me just write over here. The sensor that we are going to use, it is an optical. It is an optical sensor. Okay. Now, when we talk about optical sensor, so it has two major components in it. Let me just highlight this. Okay. So when we talk about any optical sensor, it has two major components in it, and they are as follows. That is, the very first thing is transmitter. The very first thing is transmitter. Okay. Sometimes it is also known as emitter. Basically the logic is same. Okay. Just the thing is that the names are different. Okay. And the second part is receiver. Receiver. And sometimes it is also known as detector. Okay. Sometimes it is also known as detector. Okay, I hope you all guys are comfortable up till here. Again, I'll repeat. See, what we saw just now, we saw the block diagram. Okay, and we want that our method should be cost effective and it should be non-invasive. So for that very purpose, we are going to use one optical sensor. Okay, so this optical sensor has two major components in it. That is transmitter, which is also referred as emitter, and it has second major component, that is receiver, and sometimes it is also known as detector. Okay, I hope you understood everything up till here. Okay, so now let me ask you one more question, that what exactly it will detect? Any idea what exactly it will detect? You can reply in the chat section. Yeah, this was actually a right answer. PPG sensor. I think it is given by Rasik Kedar, if I'm not mistaken. PPG sensor is again a part of optical sensor. That's good. Okay, so now the next question is what we should detect. It's fine. You can switch on your mic and you can give the answer as well. It's fine. No optical sensor. How come it can give strain and pressure? No, it can't give strain and pressure. See, my question is, let me go back. See, this particular optical sensor, it is present above this skin surface. So what particular thing it will record inside the body? Inside the body, there will be certain movement, right? Now I'm not revealing that what that particular movement is, but inside our body, there is certain movement going on. So it needs to capture that particular movement. So what is that particular movement, or what is that particular action that it needs to capture? Any idea? Any rough guesses? Heartbeat. What heartbeat? I mean, we are dealing with this particular project only. Any idea, or should I reveal that? Okay, so I'll reveal this particular thing with you all guys. Now, let me proceed further. Okay, and I hope that you all guys might have watched this particular famous movie, Fir Hera Feri, and there is one iconic dialogue in this particular movie, Mere to dil mein dhak dhak ho rela, right? I hope you all guys remember this particular dialogue, and you might get same kind of feeling during Vivas or maybe during 80 marks ka paper, right? Right? And some कुछ कलाकार लोग रहेंगे, उनको तो लाइक 80 मार्क्स का पेपर में तो धक धक इंटू इन्फिनिटी होता रहेगा, राइट? आई होप you might have had this kind of feeling during exams and vivas, right? Okay, so what this particular guy, that is Babu Rao, was talking to this particular guys, that is Sham and Raju, was this. That means relaxation and contraction of heart, contraction and relaxation of heart. So we'll try to understand this particular process. You see, this is my heart. Okay, and when this particular heart is contracting, you just focus on this particular part, that is this particular word, that is contracting. So when my heart contracts, it pumps the blood to the arteries. Okay, it pumps the blood into the arteries. Now you just see this particular part. You can clearly see that the arteries, the shape of arteries, it is completely deformed. That means it has expanded. So I'll just write over here. Let me just write over here. This particular part, it indicates that my artery is swelled or it is expanded. Okay, it is swelled or it is expanded, right? And on contrary, if you look over here, you see my heart is now relaxing. It is trying to take blood from the veins, right? Okay, I hope you are able to understand this. So at this particular time, you see this arteries, it is relaxing, right? It is relaxing, or again, it is regaining its original position. So at this particular point, what I can say is that my artery is relaxing, or it is contracting. It is contracted, is contracted, is contracted, or it is relaxed. It is in relaxed position. Okay, I hope you understood this particular part. Okay, so now let me proceed further. And now you just have a look over here. Over here, I'll just try to read this particular paragraph which is present in front of you. See this particular point from here to here. Okay, I'll just try to read this particular paragraph. So let me start. See, um, first of all, let me see if this is visible. Let me just ask if this particular slide, if it is visible to you all guys. See this particular part, is it visible, or should I zoom
Yes,
it?
sir.
Okay, okay, great, great. So still I'll zoom it a bit. Okay, so you see, we just need to focus upon this particular part or this particular paragraph that is over here. Reflection type pulse sensor, that is optical sensor, as I had mentioned, for heart rate monitor, emit infrared, red or green color light whose wavelength is this much, 550 nanometers. Okay, towards the body and measure the amount of light reflected using a photodiode or a phototransistor. So as I had mentioned that we have a detector. So detector can be a phototransistor or it can be a photodiode as well. Okay, great. So now this is the most important point. Let me erase the this one.
सर आप थोड़ा जूम कर सकते हैं.
Okay, okay. By the way, don't call me Sarah. You can call me Swarit. Wait, wait. I'll just zoom it out. I think ये zoom नहीं हो रहा है, but now is it visible? Hello.
Yes, sir.
Okay, okay, okay. So you see over here again. I'll start from here only. Reflection types. Reflection type pulse sensor, optical sensor for heart monitor. As I had mentioned, it emits infrared, red or green color light whose wavelength is this much, that is 550 nanometer, towards the body and measure the amount of light reflected using photodiode or phototransistor. So basically these two are my detectors. You see, photodiode or phototransistor, these two are my detectors. Okay, and then this is the most important point. Oxygenated hemoglobin present in the blood of arteries has characteristic of absorbing incident light. This is the most important point we should note. Oxygenated hemoglobin, that means, in our hemoglobin, if the oxygen molecules, if they are excess in number, so it has tendency to absorb the light which is incident on it. Okay, getting my point? Okay, so by sensing the blood flow rate that changes following heart contraction over time, we are able to measure the pulse wave signal. Okay, just ignore this, but we need to focus upon this particular point. Oxygenated hemoglobin present in the blood of arteries has the characteristic of absorbing the incident light. So everything is clear up till here. Let me just ask, let me just see. Everything is clear up till here. Hello, everything is clear? Should I move forward?
Yes, sir.
Okay, okay. So now let me proceed further. Okay, now I'll again read this particular paragraph for you all guys, and someone has mentioned in the chat section. Let me just see his or her name. That is PPG sensor. Yeah, this guy, Rasik Kedar, he has mentioned this particular type of sensor, or the sensor which we are going to use, that is PPG, photosplethmography sensor, is known to be very challenging. So what I'll do, I'll just read this particular paragraph as well, and we'll try to take certain points from this particular passage as well. So you see, a PPG sensor is known to be very challenging, as illustrated in figure 1. Light emitted by PPG sensor is mostly absorbed by the body tissues. The amount of light reflected depends on several factors, one of which is a volume of arteries near the skin surface. Then this is the most important point. Blood in the arteries and arterioles absorbs light better than the surrounding body tissues. So as they contract and swell in response to pulsating blood pressure, the intensity of reflected light rises and falls. Okay, so I'll just mark this particular point. Okay, and then we'll try to decode the thing that is available in or that is being mentioned inside this particular sentence. Okay, so you just have a look over here. uh, when the arteries, when they contract, okay, when they contract, so you see the reflected light rises. The reflected light rises. That means we are talking about this particular condition as I had mentioned. Let me go back. Yes, you see this particular thing over here, my arteries is contracted. This is what I had mentioned, right? That means it is in relaxed position or it is contracted completely, right? So you see over here my arteries when they are contracted. So you see majority of the light, it is reflected back to the detector, right? I hope you are getting this particular point. So let me just write over here. When my artery contracts, so the light is reflected back to the detector. Okay, and now you just focus upon this particular part. When the artery swell, the intensity of the reflected light, it falls down. That means what? Majority of the light which is incident on this particular artery, it has been absorbed by this particular arteries only. That means the blood which is present inside the arteries. I hope you are getting this particular point. So let me just write over here. My artery, it is uh, swelled, right, or it is expanded. So since it is expanded, so it will carry a huge amount of blood as compared to this particular condition. And as I had mentioned, the oxygenated blood has tendency to absorb light, right? So you see majority of the light which is present inside this particular so majority of the light which is incident on this particular artery, it is being absorbed by the blood itself, right? So light reflected would be less, or basically light is absorbed. This is what I'll write. Light is absorbed. Okay, light is absorbed. Okay, I hope this is clear. Can someone acknowledge? Should I proceed further?
Yes, sir.
Okay, okay. So now let me proceed further. Okay, so this is what I had mentioned. You see, uh, over here, if you could see very clearly, let me just zoom this particular image. Yeah, you see over here, this particular part, it has been clearly mentioned that my artery is contracted. Let me use certain different color. Yeah, you see my artery is contracted. That means we are talking about this particular condition. Okay, and you see the hemoglobin molecules that are available in this particular condition, they are very less in number. Hardly we can see 3 to 4 hemoglobin molecules. So you see, due to which the light emitted by this particular LED, it is reflected back to the photodetector, so it will sense huge amount of light. Okay, on contrary, if you look over here, let me just move it little above. Okay, if you look over here, now we are dealing with expanded one. So when my artery, it is expanded, so you see it will carry huge amount of blood. That means the hemoglobin molecules which are available inside the artery, it is huge in number, right? So you see over here, hardly we have 3 to 4 hemoglobin molecules, whereas over here there would be around 10. I'm just taking a random number. So due to which, what is going to happen? So this particular hemoglobin molecules, they are trying to absorb the light which is incident onto them, right? And you see hardly some part of the light, it is getting reflected back to the photodetector, right? So this is how it actually works. So what we can do over here, let me just erase this particular thing. Let me just zoom it out. Just a second. Let me bring this particular image as well. Okay. So you just have a look over here onto this particular part. Take this particular color. Yeah, you just have a look over here. When my arteries, if they are expanded, okay. So when my artery, if they are expanded, that means we are dealing with this particular condition, right? We are dealing with this particular condition. And now you see, as I mentioned that the intensity of light which is detected by this particular photo detector, it is very less, and that's why if you look over here, we are getting a signal of low amplitude. we are getting a signal of low amplitude. You just have a look over here. We are getting a signal of low amplitude. Okay, this sudden analog signal. As of now, that is not a concern for us. Like, what is the amplitude of the signal? Okay, we don't need to study its characteristic. We just need to analyze the signal, right? So, what kind of signal we are getting with this particular area from this particular area? Sorry. So, what we can say is that we are getting this kind of curve. You see, we are getting a low amplitude signal. Now, if you look at this particular part, mm, yeah, somewhere over here, you see the hemoglobin molecule which is available, it is very less. Over here it is shown one only, right? So let me just use this one. I'll just highlight it over here. So you see, in this particular scenario, majority of the blood, it is reflected back to the photo detector, and that's why if you see over here, we are getting certain high amplitude of signal, right? Something like this. So that's why it is following this particular curve, right? Now we don't need to focus upon like why exactly this is happening, right? We don't need to focus upon this. That is not a part of our interest. Okay, I hope this is clear to you all guys. Just someone acknowledge. Can someone acknowledge? Shall I proceed further?
Yes, sir.
Okay, okay. So now what I'll do, I'll just conclude this particular entire thing by writing certain points. So let me just write first point over here. Blood is present inside the arteries. Blood is present inside the arteries. Right. Now let me go with the second point. What we know is that blood has certain hemoglobin molecules in it. Blood has hemoglobin molecules in it. Right. And we also know that oxygen binds with hemoglobin. Oxygen binds with hemoglobin. Okay. So now again we'll try to revise the entire concept. Okay, that will help us to understand, how to process further. Okay. So you see, as I had mentioned over here, let me change the color. Yeah. So as you see, again I'm repeating, as my arteries are expanding, so the hemoglobin molecules, let me just write over here. See, as my arteries are expanding, so due to which what is going to happen? The blood present inside the arteries. That means I'm talking about this particular area. Okay, I'm talking about this particular area. So the blood present inside the arteries, it is going to increase. Thus, the hemoglobin molecules, the amount of hemoglobin molecules present in that particular area, it is going to increase. And due to which, what we can say, the oxygen available or the oxygen has tendency to bind the hemoglobin, right? And due to which, what is going to happen? We just now saw, just 2-3 minutes back, we saw that oxygenated hemoglobin present in the blood of arteries has tendency to absorb the incident light, right? So due to which it will absorb it will absorb light, right? This is what we saw. So you see all of this particular line, they are proportional to each other, right? All of this particular line, they are proportional to each other. On contrary, if the amount of blood present in the arteries, if it decreases, so your hemoglobin molecules also decreases. Thus, O2 which are present in that particular hemoglobin molecules, or rather in the blood, it also decreases, and thus majority of the light, it is reflected back. Getting my point? Okay, understood everything up till here, guys? Just let me know. Shall I proceed further?
Yes, sir.
Okay, great. So now let me again go to the blackboard. Okay. Okay, so this is how the block diagram looks like. So if you see over here, this was kind of a rough block diagram, right? Because we don't have had any prior idea that how we are going to proceed further. What we were knowing was we will get certain signal from the sensor. It will be getting fed to the controller, right? But what exactly will happen, what kind of signal we will get, from where we are capturing this particular signal, no, that we were not knowing. Right now we know all of these particular things, and we also know that which kind of signal we are going to receive, right? So we can easily play with that. So now let me explain you this particular diagram. Okay, so you see, as I had mentioned, we will receive this kind of waveform, kind of, it is an analog waveform, right? And after this particular, after this particular part, this particular analog waveform, it is given to the signal conditioning circuit. Okay, so in signal conditioning circuit we have, lots of components. Like, with the very first thing should be a capacitor, which will actually filter the DC part, right? And then we have filters, amplifiers, comparators, ADC, etc., etc. Lots of components are present inside it. Okay, so what is the reason that why exactly we are connecting this particular signal conditioning circuit, or rather what is the agenda to connect this particular or to provide this particular signal conditioning circuit in between controller and this particular sensor? Any idea? Kindly acknowledge. Any idea? Rashid, Kedar, I don't have any idea because I have not worked on this particular project, but I'll search. I'll give you the appropriate reason. Not now, but maybe in future. Maybe, after 2-3 weeks, I need to search in that as well. Okay. So yeah, any idea that why exactly we are connecting this particular signal conditioning circuit? Any idea? Any rough guesses? Hello, can someone acknowledge? Do you guys have any idea? Yeah, that is one reason, but there are two major reasons. There are two major reasons. I want those particular reasons. Yes, amplification. Great. Amplification. Yes, yes. Correct, correct, correct. Yes, great. And may I know the second reason? Can someone guess the second reason? Yeah, noise reduction is again a part of it. As I had mentioned, we are using filters for that only. But this is correct answer. No, amplification. Sumit, this guy gave the correct answer, and then followed by Shraddha and Abhinav. May I know the second reason? Second important reason. I'll just give you a hint that we are actually using. Oh, wait. Yeah, we are actually using a controller. This is a kind of hint. Can you guess the second reason for this? Any idea? No idea? Okay. So let me explain you this particular part as well. See, as Sumit mentioned, which is the right answer, that is the first point. Let me use this one. Yeah. So this entire thing will act as a sensor for me. Just a second. Let me move it a little below, and let me write over here that this is my sensor. This entire block will fit inside a sensor only. Okay. So as Sumit mentioned, the very first point is of amplification. So we are going to perform amplification. Okay. So we will amplify this particular signal, and after that we need to convert it into digital form. Digital form, and that's why if you look over here, we can either use comparator or ADCs. It depends upon the circuit. Okay. So why we need to convert it into digital form? Because our controller, I mean, it cannot interpret analog signal properly, because if you see microcontroller, it comes under digital electronics only, right? So to read this particular signal properly, we are actually converting this particular signal into digital format. So for that, we will filter out the noise. That is also a correct answer, but the most important point was amplification and to convert it into digital format. Okay, I hope you are able to understand this. Great. So now again, if you see what we are going to monitor over here, now whatever the signal that we will get, that will be acting as the input to this particular microcontroller, right? So what we need to monitor, so let me just show it to you. You see, uh, we are getting, hello, any doubts? Yeah,
No.
Riddhi gave the correct answer. Conversion to digital form. Yeah, that is right. Great. Okay, so I'll move forward. So what we need to monitor? So we need to monitor this particular part. You see over here, this is my analog signal, right? We'll get this kind of signal. We are converting it into digital format. So our digital signal should look something like this. So we should monitor this waveform that is going from 0 to 1. That is going from 0 to 1. Okay. I hope you are able to understand this, because you see over here we have 0. So this particular condition will occur when we have a hemoglobin molecule in excess, right? That means our artery is expanding, right? So it indicates that my artery, it is expanding. I'll just write it in short form. So AE, it will indicate that my artery is expanding, and this will indicate that my artery is swollen, or it sorry, my artery is contracting, right? This will indicate that my artery is contracting. Okay, great. So now let's proceed further. Okay, so now we are going to understand that why exactly we are using microcontroller. Okay, why exactly we are going to use a microcontroller. So as I had mentioned, we are actually providing 0 to 1. I mean, we are getting a 0 to 1 pulse, right? Low to high pulse, something like this. So we need to focus upon this particular transition of the pulse. Okay, so what we are doing over here, let me just write over here what exactly is the agenda, like why exactly we are using a controller in this particular application. So let me just write over here, then it will be pretty easier for you to understand this particular concept. Okay, so microcontroller, I'm writing it in shorter form. Microcontroller should catch microcontroller should catch the low to high pulse, low to high pulse, low to high pulse, that is 0 to 1, right? 0 to 1, this kind of pulse. And let me just show it in this way. 0 to 1 pulse, that means it resembles that it is transitioning. Okay, so 0 to 1 pulse for around 1 minute, for 1 minute, which is almost equivalent to 60 seconds, right? For 1 minute, and then display that particular data, display it on, I mean, display data onto the LCD, display data onto the LCD. This is our agenda. So with this particular line, we can actually understand two things. Okay, with this particular line, we can actually understand two important things, and those are as follows. The very first thing is this, that is, see, we need to catch low to high pulse. This particular point, we need to catch low to high pulse. That means we need to count, the number of pulses which are occurring within a minute. Okay, within a minute. Again, I'll repeat. Our microcontroller should catch a low to high pulse. That means a 0 to 1 pulse for around 1 minute. What does that mean? That means our microcontroller, it will act as a counter which will count the events. Which events? This particular events. That means when our pulse is going from 0 to 1. Okay, great. Now the second point is it should also act as a timer so that it can actually provide a delay of 1 minute or 60 seconds to be precise. Okay, so it has to do two tasks at the same time. It has to do two tasks at the same time. That is, it needs to act as the counter. On top of that, it needs to act as a timer as well, so that it will count the event, and parallelly it will count the time as well. Okay, and then this particular event which it is counting, it needs to process that, and it needs to be displayed onto the LCD. So you see over here, we had certain analog signal over here, we had certain digital signal over here, and now we are getting certain data in the readable format. That is whatever that heartbeats are, 90, 30, 100, whatever that is. That is not the point of our interest. So you see how exactly we are moving. Are you able to understand the approach that we are actually following in this particular entire project? You see, we actually learn the concepts of bioinstrumentation and sensors. We actually saw which sensor to use. We also saw its working, right? And also we took into account the biology aspect as well, the flow of heart, the contraction and relaxation of heart. And then we also saw signal conditioning circuit. I mean, uh, we had just seen it in the brief way. We had not seen how exactly it is made and all. So if you want to understand that how exactly we can make a sensor, don't worry, I'll upload one video on it on my YouTube channel, so please follow me on YouTube as well. So I'll make one sensor which can actually detect the heartbeat. So I'll elaborate that particular part as well. Okay. And then we had this particular controller, right, which will actually convert this data into the readable format. So you see, we are actually using sensors, bioinstrumentation, biology part, analog electronics part, digital electronics part, controller. Okay, so these are the certain concepts that we are using. I hope you are able to understand this. Okay, any doubt up till here, or should I move further? Any doubt? Should I proceed further?
Yes, sir.
Okay, great. So now let me proceed further. Okay, so now we need to analyze controller part. So I believe you might have a good idea about 8051 controller, at least a basic idea that it has 4 ports. Okay, 4 IO ports: port 0, port 1, port 2, and port 3. So uh, can anyone tell me which port should we use as the input port, provided I had clearly mentioned that we are using it as a timer and counter, and which port should we use as the output? Can anyone tell me which port should we use as the input port? Any idea? Any random guess? Any idea that will help me to explain you this particular concept? Which port should I use? AD pins? No, I'm asking about ports. I'm not asking about the pins. I'm specifically asking about the port. Port 0 as input? No. See, I had clearly mentioned port A. भाई पोर्ट ए कहाँ पे आया यार? 8051 में पोर्ट 0, पोर्ट 1, पोर्ट 2, पोर्ट 3 आता है. Which port should we use? चलो भाई, किसने तो पोर्ट 0 लिखा है, कोई तो पोर्ट 1, पोर्ट 2, पोर्ट 3 लिख डालो. Because we also used to do same thing. Port 0 wrong, port 1 डालो, port 1 wrong, port 2 डालो, port 2 wrong, port 3 डालो. कोई ना कोई राइट आ ही जाएगा, राइट? Okay, so let me reveal that. Okay, so basically, uh, yes, I can hear someone. Port 3. No, why we will use 2 ports? We just want 1 port.
Hello.
Yes, I can hear you. Who was that guy? You can turn on your mic and you can give me the answer as well. No issues. Okay, so I'll reveal that. So we are going to use port 3 as the input port. So we are going to use port number 3, port 3, port 3 as the input port, and you can use any port as the output port. You can use either port 1, port 2, port 0 as well. I'll go with port 2. Okay, port 2. Why we are only using port 3 for the input? So for that, let me just show you this particular thing where it is. Just a moment. Yeah, you see over here in port 3 we have two important things that are two timers. If you could see very clearly, yeah, you just have a look over here. In port 3, pin number 4 and 5, you just have a look over here. Where we have two things, that is T0 and T1. So these are timers. Okay. So these are my timers, and that's why I'm focusing on port 3. I'll use it as the input port, and you can use any of this port, that is port 0, port 2, port 1 as your output port. Okay. I hope this is clear. Everything is clear up till here. I hope everything is absolutely clear up till here. Okay. Everything is clear. Okay. अरे don't call me sir यार. Call me Swarit. आपसे एक आध दो साल ही बड़ा रहूंगा, ज्यादा नहीं. Okay. So now
Yes,
what
Anil.
we'll do? Ah, yeah. Yes. Yes. Any doubts? Hello.
Yes, sir.
Okay. So now what we'll do? We'll take a break of 2 minutes because I don't want to bombard you with all of the concepts within a go. है ना? थोड़ा रेस्ट लो वरना रेस्ट इन पीस हो जाओगे. थोड़ा रेस्ट लो. देखो एक बार क्या क्या पढ़ा. You see, we learned the block diagram. After that, we saw the sensor which we used. We also saw part of biology over here. Then we actually saw the working, and then we also came to know that what kind of signal we got, kind of analog signal. Okay, and after that we saw that this particular circuit, it is converting it into digital format, the analog form into digital one. And after that, uh, we saw the overall block diagram, and we also saw the application of controller, like what application of controller that we are going to use over here. Okay, and as I mentioned, we are going to use port 3 for timers, port 2 for output to display certain things. Okay, great. So till then, I'll just take a break of 2 minutes, and till then just scan this particular image and do subscribe to my channel. I'll join within 2 minutes. Okay, till then just make sure to scan this particular image. आपको भी अगर किधर जाना वाना रहेगा, थोड़ा 2 मिनट में घूम के आ जाओ. Okay.
Sorry, this QR code is for Udemy course. कहाँ गया बता?
All right. Hello, am I audible? Shall we start this session? Should I proceed further? Okay. Okay, so now we are going to understand the timer operation with 8051. How exactly we are going to use 8051 as a timer. Okay. So I believe आपको थोड़ा बहुत idea रहेगा. You might have a bit of idea about how to use timer or how exactly we are going to perform timer operation with 8051. Okay. Even if you don't have that much of idea, don't worry. I'll explain you very shortly. So in 8051 we have one register. Okay, there is a difference between resistor and register. Resistor, RESIS, it is something which is which opposes the current, and register, REGISTER, it is something which is used to store certain data. It can be a 1 bit, it can be a 8 bit. Okay, so you can clearly see over here, this is my TMOD register which is present inside the 8051 microcontroller. So it is clearly mentioned over here that this is my TMOD register. Okay, so this is my TMOD register, and basically my TMOD register, it is a 8-bit register. My TMOD register is a 8-bit register or 1 byte. So basically it can store 8 different data. Okay, that means 0 1 1 ऐसा कुछ 8 ones or 8 0, something like that. Okay, getting my point? Let me erase this. I'll just write it properly. So this is timer 0 and this is timer 1. It's timer 0 and this is timer 1. Okay. So now we will try to understand what exactly is a TMOD register. So basically a TMOD register is a register which holds 8 bits, and this particular bits decides the operation of timers. So you can clearly look over here. Just a few minutes back, I had just shown this particular thing to you all guys, that we have two different timers over here which are available on 8051, right? So whether to use this particular timer for timing of whether we can use this particular timers for creating a delay, that means to use it as a timer operation, or should we use it to count certain events, that is to use it as a counter operation. So this particular thing, it is decided by tmod register. Okay, I'll just write it very shortly. So tmod, let me change the color. So this particular tmod register, tmod register, it controls it controls whom? It controls the T0 and T1, which are the timers which are available in 8051. T0 and T1. Again, I will repeat. See, TMOD register, it is a 8-bit register, so it can store 8 different values. On top of that, what it will do, it actually controls T0 and T1, that are the two timers that are available inside the 8051 controller, as you can clearly look over here, T1 and T0. Okay, great. So now we will try to understand the function of each and every bit that are present inside this particular register. So you see over here we have M0 and M1, which decides the mode. Let me change the color. Yeah, you see over here we have two modes, M0 and M1. M0 and M1. These are the mode. Okay, decides the mode. I will come to this particular part. Don't worry. You see this particular bit, CT bar. CT bar. It decides, whether I want to operate this particular timer, that is timer 0 and timer 1, as a timer for timer operation, or I need to operate this particular two timers as for the counter operation. Okay, so this particular bit decides that, and we have gate bit. Okay, don't need to worry about that. It's not a big deal now. I'll explain this particular part. Don't worry. And any which ways, we are not going to use this particular bit for this particular project. Okay, great. So now let me read all of these particular points over here. That is represented mode 0 and mode 1. So you see M0 and M1 bit which are present over here. If these particular bits, if they are 0 0, okay, so that means we are selecting 8-bit timer counter operation. Okay, so basically it is not 8 bits, it is 13 bits. In reality, it's 13 bits. So we can use 13 bits. So you see over here, as I had mentioned, that the timers that are available in 8051. So this particular timers, they are of 16 bits. So you see over here timer 0. So this entire thing is my timer 0. See this entire thing, sorry, this entire thing is my timer 0. It comes under the timer 0, and you see timer 0 is divided into two, that is TL0, the lower bytes and the higher bytes. So it will hold 8 bits of data from D0 to D7, and this one, it will hold another 8 bits of data D8 to D15. So when I select mode 0, just a second, yeah, when I select this particular mode, so I'll be only using 13 bits out of it. Okay. On contrary, if I'm selecting this particular bit, that is this particular mode, that is mode 1, that is 0 1. If I'm giving this particular bits to M0 and M1, so I'm selecting this one. So in that particular uh, in that particular with that particular mode, we can actually go with 16-bit timer counter operation. That means what? We are going to use all of this particular 16 bits. Okay, from D0 to D15, we are going to use all of this particular bits of timer 0, and obviously it depends on timer which we are going to use. So as of now, I'm just focusing on timer 0. If you are focusing on timer 1, so you can use timer 1 as well. You can clearly see same bits are available: M0 M1 CT bar gate, M0 M1 CT bar gate, right? Okay. So in our project, we are going to focus upon this particular mode, that is mode 0, which is a 16-bit mode. Let me write it. Yeah, let me just highlight it. We are going to use this particular mode. Okay. And then there is another mode, that is 8-bit auto reload mode. Okay. You can also go with this one. So generally, in general, if you are going with 8051 microcontroller, generally these two modes are preferred, and the another one, they are not that much preferred. This one and this one, sorry, mode 0 and the other one, they are not that much preferred. Either mode 1 and mode 2 are the most preferred modes in case of 8051 controller. But we are going to use the 16-bit mode only. Oh, sorry, that is mode 1, that is 16-bit one. Okay, that means we are going to use all the 16 bits that are present inside the timer. Okay, great. I hope you all guys understood everything up till here. Any doubts? Any doubts? Or should I proceed further? Any doubts up till here? Can someone acknowledge? No, sir. Okay. So now let me proceed further. And this is the snapshot of my own notes, where you can see over here, as I had mentioned, timer 0, it is divided into TH0, that is higher bytes and lower bytes, right? Similarly, a timer 1, higher bits, lower bits, right? And we had T-mode register. This is what I had written, right? I had just written it very roughly. This is how I make notes, right? I'm not that much fashionable. Okay, you all guys might use certain 3 to 4 different colors of pen. I just use 1 2 pens. That's it. So you see over here, CD bar, if it is 0, that is, it will, that means our timer 0 or 1, it will do, or it will perform timer operation. Okay, it will perform timer operation. You just have a look over here. If my CT bar it is 0, it will perform timer operation. Okay, and if my CT bar, if it is 1, then it will perform counter operation, right? And gate is 0, so timer and counter is enabled whenever TRX control bit is set. Software. Okay, so now basically we are enabling these two bits, I mean this CT bar and mode and all, we are enabling them with the help of software, so no need of gate. Okay, so if you are using the hardware method, which I'm not discussing over here, so you need to at that particular time you need to make gate as 1. Okay, as I can clearly see, this is the, as I had clearly written over here, this is the hardware method. Okay, and you see this is 13-bit mode 0, mode 1, mode 2, mode 3. So basically we when we are dealing with 8051, we go with either mode 1 or mode 2, but in this particular project we are specifically going to focus upon the mode 1. Okay, now let me just write one more point over here, and that is this one. So when I say that, I want, if you can just recall this particular part where I had clearly mentioned that we are going to use 8051 or this particular controller for counting the events. That means this particular events, right? And we are going to use this particular timer for creating a delay of 1 minute, right? So basically we are going to use both the timers that are available in the 8051. Okay, you see that is timer 0 and timer 1. That means we need to operate timer 0 for timer operation or counter operation, or else we need to operate timer 1 for timer or counter operation. Okay, that we will see which timer we are going to operate as a timer and counter. Okay, so that means what? When I say that my CT bar is 0, that means that particular timer will perform the timer operation. That means it will, in our project, what it will do, it is to create responsible to create a delay of to create a delay of 1 minute, which is equivalent to 60 seconds, right? It is with this, what we can do, we can actually create a delay of 1 minute. Okay, 1 minute. Okay, and then we have this one, that is counter operation. So we are going to make this as one with certain timer to ensure that we are counting the pulses, counting the pulses. And what are those pulses? That means the events, as I had mentioned, transitioning events 0 to 1. We are going to monitor that particular pulses or this particular events for 1 minute. Okay, and for that we are going to use this particular bits. So just remember this particular point. We will discuss this particular concept as we go further and further in this particular session. Okay, great. So now let me proceed further, and as I had mentioned that uh, this is the timer 0 and this is the 16-bit timer. Okay, you see we are using all the 16 bits. I'll come to this particular point, don't worry. Now let me proceed further, and now we'll straight away jump on to how we are exactly going to use timer for the timer operation or to create a delay. Okay, how we are going to create a delay with this particular timer register. Okay, so everything is clear up till here. Shall we proceed further? Everything is clear or not?
Yes, sir.
Okay, great. Just a minute. Okay, so remember one thing, in 8051 to execute one instruction, 8051 take 12 t states, yani something like this. You see, it requires 12 t states. ऐसे 12 cycles लगेंगे, right? 12 cycles. So it requires 12 cycles to execute one instruction. And basically I had performed this particular mathematical operation. It is another concept, right? I don't want to involve you with this particular concept, but just remember one thing. Since we require 12 t states, so 1 by 12, and this is the frequency. Okay, this is the frequency of the crystal which we connect to the 8051 controller, that is 11.0592 megahertz, and this is the frequency that we get. So from here, exactly what we are going to calculate is the time required for 8051 to execute one instruction, and this is that particular time, that is 1.085 microsecond. Okay, so remember one thing, to execute one instruction, to execute one instruction, execute one instruction in 8051 or with 8051 microcontroller, the time required is this much. The time required is around 1.085 microsecond. Okay, I just kept this particular image just to show that from here we got this particular value. Okay, because we are going to use this particular value again and again when we are solving certain numericals. Okay, I'll just show you certain things. So at that time, no one should ask कि ये कैसे आया. Okay, just a rough idea. Okay, because this totally is a different concept. I don't want to involve you in that. Okay, then we have one more register. As I had mentioned, register is something which will store the data. So when like we have one more register, that is TCON register, that is present inside the 8051 controller, and this is responsible to start and stop the operation. Which operation? That means the operation which we saw just now. That means this one, that is timing operation or counting operation. Okay, so this TCON register has 4 important bits. So just as of now, just neglect this particular part. That is this one, interrupts and all is not required as of now. Just focus upon TF1, TR1, TF0 and TR0. So TF, this particular register bit, that is TF bit, uh, TF bit, it is responsible to stop the operation. I'll just write it in this way, responsible. It is responsible to stop the to stop the operation. And I'll write one more thing over here. Basically, it is an overflow flag. So basically, we need to monitor it. Monitor this particular flag. Okay, I'll come to this particular part. Don't worry. Then we have another bit that is TR, and it is responsible to start the operation. TR is responsible to start the operation. Sorry, start the operation. I hope this is clear, guys. Okay, now uh, let me proceed further. Okay, and these are the certain steps through which we are going to create a time delay. Okay, so what I'll do, I'll take one example. I'll just try to explain you that particular example by following these particular steps. Okay, so I hope you all guys might have worked with Arduino. Can someone acknowledge that have you all guys might have worked with Arduino or not? I believe that you might have worked with Arduino. Just acknowledge, guys. हाँ ना बोलो, कुछ तो बोलो. No replies. Okay, so I will assume that you all guys might have worked with Arduino. So Arduino में एक signal रहता है. Let me just show it to you. There is one pin that is PWM. Yes, I'm getting replies from Shraddha and all. So Arduino, let me just see if I can show it to you now. Yeah, you see this particular pin, PWM. So you see pin number 3, 6, and 5, all these particular pins, they are responsible to create a PWM signal, right? Which through which you can control the motor, right? So basically the same concept is used over here. That is, you can see in pin number 3, 6, and 5. So we are actually trying to create a same kind of logic. Okay, we're going to create a square waveform. Okay, so basically we are going to create a PWM. We are trying to you know uh, create a kind of PWM kind of logic. So it is somewhat similar to that only. I hope you are getting me. So now this is the question, that is generate a delay of 10 millisecond using timer 0 and mode 1. So that means what? I need to use, when I say mode 1, that means where it is. Yeah, I need to use all of these 16 bits which are present in the timer 0. So we need to create timer 0. Sorry, we need to create a delay of 10 milliseconds uh, with timer 0 using mode 1. That means we need to use all these 16 bits. Okay, great. So now let me move over there. Okay, so what we'll do, we'll just read this particular thing which I had mentioned over here. So these are the steps. Okay. Right now you don't focus on this one. We'll focus when we will see the programming part. As of now, you just don't focus upon this part. You just look at this particular paragraph over here, or the notes which I had written over here. So the very first step is this, that is divide the desired time delay by 1.085 microsecond. So this is the very first step, divide the desired time delay by 1.085 microsecond. So very first step is that this is my desired time delay which I want to create, that is 10 millisecond. I have to divide it by 1.085 microsecond. Okay, so when I do this, what value should I get? Let me just calculate it. Let me just calculate it. If you want, you can also calculate it. So 10 into 10 raised to minus of 3 divided by 1.085 into 10 raised to minus of 6. So it gives us this particular value, that is 9216. 9216 point something, but it's fine even if we take 9216. Okay. Now we need to focus upon the second step, and it states that perform this particular operation, that is 65,536 minus of n. What is n, by the way? Where n is the decimal value which you got from step 1. That means whatever the value that we got over here, in our case it is this one, that is 9216. So we need to subtract it from 65536. Okay. Now I know most of you all guys will question me why we are actually subtracting it from this particular value, that is 6556. 536. We need to subtract 9216 from it. So the reason is quite simple, because we are using, if you see over here, yeah, we are using mode 1. Mode 1 is of 16 bits. That means 2 raised to 16 is how much? Just calculate this particular value. It is almost equivalent to this. It is almost equivalent to this 65536. So that's why we are actually subtracting this particular value from this one. Okay, I hope you are getting this particular part. Okay, is everything clear up till here? Can someone reply? Hello?
Yes, sir.
Okay. So the value that we will get from this particular calculation, that will be equivalent to this, that is 56320. 56320. So this is the decimal value which we are getting. Okay. So now we'll move to the next step, and that is convert the result of step 2 to hex, that is YYXX. So whatever the result which you got in the step 2, that means over here, the decimal value which you will get, you need to convert it into the uh, hexadecimal equivalent. Okay, so the value which we got over here was this, that is 56320. So we need to convert it into hex format. Okay, so this is the decimal, and we need to convert it into hexadecimal. Hexadecimal. Okay, hexadecimal. So let me go to my Chrome and let me just write over here decimal to hexadecimal. Let me just put this value inside this particular calculator. That value is 56320. So I'll just put over here 56320. Yeah, and then I need to convert this particular value into hex. You see, I need to convert this value into hex, and this is the value that I will get, that is DC00. DC00. If you want, you can also see how exactly we got this. Okay, but I believe that you all guys know how exactly we are getting these particular values. So the value which we got is DC00. DC00. Okay, is everything clear up till here? Can someone acknowledge me? Is everything clear? Any doubts up till here? Any doubts? Yes, any doubts?
No, sir.
Okay. So yeah, let me move over there. Now we need to move to the next step, and that is this. Set TL is equivalent to XX and TH is equivalent to YY. So what does that means? We need to assign the lower byte to the TL, that means TL0 register, since we are using timer 0. So we need to assign these values, that is 00 to TL0, and then we need to assign TH, I mean the higher bits, that is, sorry, that means DC to TH0. So let me just write over here. Fourth step that we need to execute is this, that is TL0 is equivalent to 00, and then TH0 is equivalent to DC. Okay, great. Now what we'll do, we'll just execute this entire logic onto the kill software. Then we'll run this particular circuit onto the Proteus software, and we will check if we are able to get the desired delay, that is of 10 millisecond or not. Okay? So for that, let me just open the project 10. Okay, just give me a moment. Is my screen visible? Can you see this particular program over here which I had written?
Yes.
Okay. So now over here, I just forgot to tell you one thing. See, if you are using any controller, let's say if you are using Arduino, so you don't need to use this particular timer over here. That means what? That means to create a 1 minute of delay, to create this particular 1 minute of delay, you can actually use the predefined function, that is a delay, whatever that is, 60,000, whatever that is, right? But in 8051, we don't have that particular privilege to use the predefined function because it was invented back in 1980s, right? So at that particular time, most of the people were kind of hardware oriented, right? So software में किसने वो predefined function लाया ही नहीं. So that's why we need to use timer, right? We need to use timer to create that 1 minute delay. Okay. So this is what I just forgot to explain. Okay, so now what we'll do, we'll see this particular entire logic into this particular program. So as usual, this is my header file, include reg51.h. Is this program visible? Can you see this thing that is include reg51.h and all? Can you see this? Can you see this, guys? Please reply. Can you see this particular program?
Yes, sir.
Okay, great. So you see, this is my header file, include reg51.h. It is equivalent to coinio.h, which you used to write in this C program, right? Normal C program, but this is, by the way, embedded C, right? So it will contain all the things which are present in the 8051 controller. That means the port 0, port 1, port 3, and all of those particular pin numbers and all. It is present inside this particular library. Okay. Then I'll create void delay function, because as I had mentioned that we don't have that privilege to use the predefined function, as it is not available in case of this particular controller. Now just have a look over here to the pin number 0 of port 2. I'm going to connect LED. Just a second, let me open that as well. Let me just show you the hardware part of this, then it will be pretty easier. Okay, let me just zoom this. Okay, so you see, this is my port 2, by the way. If you could see, yeah, you see, this is my port 2. Okay, and you see over here, I'm using pin number 0 from port 1. This is P 2.0. P 2.0, that means port 2, and this is my pin number 2. Sorry, pin number 0. Okay, so now let me erase this, and we'll again go back to the kill software to understand the program. Okay, so this is a data type as bit. That means it can hold only one bit, either it can be a 0 or it can be a 1. So I define this LED is equivalent to P 2 caret 0. That means I had connected LED to this particular pin number 0 of port 2. Then this is my main function. Port 2 is equivalent to 0x00. So when I define this, that means what? That means, oh sorry, this is my output port. Output port. Output port. So you need to connect certain output system. In our case, it is LED, right? So we are connecting LED over here. We are actually monitoring this particular LED. That is our output, right? And then we are creating a while function, while one. That means if it is true, so it will be executed or iterated infinite amount of times. I believe that you all guys have a basic understanding about C programming. So LED is equal to negation of LED. So for time being, let's assume. Let me take one. Yeah. So let's assume at the very first instance my LED is in on condition, right? Then after this particular instruction, my LED will be in off condition, and then I had created this particular delay. Okay, So it will be in off condition for certain delay. In our case, it will be in off condition for 10 millisecond. Again, since this particular while statement, I've written this particular while statement, so it will iterate infinite amount of time. So after 10 millisecond, this LED will be in on condition, and again after 10 millisecond, it will be in off condition, and it will keep on doing this for infinite amount of time as we had used while loop over here. Okay, so you understood the logic over here. See, more than programming, you should always focus upon the logic. Okay, because once if you understand the logic now, then everything is absolutely easy for you. Have you understood everything up till here? Just let me know. Have you guys understood everything up till here?
Yes, sir.
Okay, so now let me again go back to the kill software. So you see, I had created this particular, sorry, now I'm expanding this particular function which I had created above, that is void delay void, since we are not returning any sort of data or any sort of values over here. So I'll just write void over here. Now you just focus upon here. T mod is equivalent to 0x00. So now let me elaborate this particular point. So my T mod is equivalent to 0x01. Sorry, 0x01. So what does that means? So 0, this particular 0, that means 1, 2, 3, 4, and this particular one means 1, 2, 3, and over here we will get 1. So now if you could remember, we had M0, we had M1, we have CT bar, right? And we had gate. So as I have mentioned, gate would be 0, right? And this particular part, since we are using mode 1, so that's why I had written 0, 1. We are using mode 1, that means we are talking about 16 bits, right? We are going to use all the 16 bits of timer 0, okay, of timer 0. And let me go back. If you could remember where it is, just a second. Yeah, if you could remember, when my CT bar is 0, it will perform timer operation, right? So over, oh, it got erased, but no worries. So I believe that you understood. My CT bar was 0, right? So over there, my CT bar was 0. So that means what? We are focusing upon the timer operation. I hope you are getting this particular point. Okay. M0 and M1 was 0, 1. That means focusing on, we were focusing upon the mode 1. Okay. I hope this particular part is clear. I hope this is clear to you all guys. Just acknowledge me, guys. Is this part clear? Yes. Okay. Great. So now let me proceed further. Okay. So you see, we had set with tmod. We are giving instruction to the controller that I am using timer 0 and I'm using mode 1, and I'm doing timer operation or timing operation. That means I need to create a delay. Okay. So the microcontroller got the instruction that it, I mean, it needs to generate a delay of 10 millisecond. This is what we know, but microcontroller don't know. So for that, you see over here, I'm giving TL0 as 0x00. Okay, so if you could see over here where it is, yeah, TL0 is equal to 00. So we need to assign the lower 8 bits to TL0 and higher 8 bits to TH0. So you just have a look over here, TH0 0xDC. So in hexadecimal, we write it in this way 0x. Okay, and then the numbers or then the things which we want to write. Okay, okay. So now with this, I hope you understood this. Now we'll come to this particular paragraph. So you see, this is what we had done till now. That is load tmod register for selection of timer or counter, right? So we had already loaded that. Then load TL and TH value, which we had already done. Okay. And then we need to start the timer. So we need to focus on this particular part. And as I had mentioned earlier only, you see uh, this particular bit. So there is one register that is tcon. So this is my tcon register, and inside it there are 4 important bits. As such, it has total 8 bits, but we need to focus upon the 4 these 4 bits only. So we, as I had clearly mentioned over here, that you see this particular bit, TR bit, it is responsible to start the operation. And in our case, the operation is the timer operation, which is responsible to create a delay, right? So you just have a look over here where it is. Just a second. Yeah, you see TR0 is equivalent to 1. That means I'm giving instruction to the controller to start the operation. Okay, now the microcontroller has got the data that it has to set the timer 0 for timing operation, right? And it has to create a delay of 10 millisecond. And now it needs to start the operation. Okay, I hope this is clear. Okay, is everything clear up till here? Is this part clear?
Yes, sir.
Okay. So now you just have a look over here. I'm using again while statement. And what does that means? That means I'm monitoring this particular bit TF is equivalent to 0 or not. And if you look over here, I had clearly mentioned over here only that TF0 it is responsible to stop the operation in the indirect way, not in the direct way. I will explain this part. So you see what exactly is going to happen over here. So for that, let me just check the binary equivalent of this. Okay, 56320. 56320. So in timer 0, we have this particular value 56320, but obviously microcontroller will store data in the hexadecimal format. That means obviously it will convert and store in decimal, sorry, not decimal, this zeros and ones binary format, but its hexadecimal equivalent is DC00, which we had already given to the or fit to the microcontroller, right? So now what exactly will happen with this? See, when I'm giving this particular instruction, that is TR0 is equivalent to 1, that means I'm asking my microcontroller to start the to start the timing operation. So what exactly it will do? See, it will keep on incrementing this particular T0, that is 56321, 56322 till 65536. Okay, 65536. That means it will exactly give us a delay of 10 millisecond. It will be exactly giving us a delay of a 10 millisecond, right? And this is what we are monitoring. So once if this T0, if it reaches this particular value, then my TF0 becomes 1. Okay, up till here, my TF0 will be 0. And this is what we are monitoring over here with the help of while statement. And you can clearly look over here while TF0 is equivalent to 0. So this is what we are monitoring. And that's why if you look over here, uh, let me first of all, let me know if this particular concept is clear. Okay, because if I switch from one software to another, so all of these particular things will be erased. Okay, just let me know if this particular part is clear or not.
Yes, sir.
Okay, great. So you see, now we need to go to the software. Just a second. Yeah, if you look over here, I had clearly mentioned that we need to monitor this particular bit, right? So TF0 is equivalent to 0. We are monitoring it, and as this particular T0, that is timer 0, reaches to 65536, then it will automatically gets reset. That means it will be 1, and then it will automatically come out of the loop. So what does that mean? That means let's assume that my LED it is in on condition. Okay, over here it is in on condition, and then it will call this particular delay function. My program will go over here, and then all of this particular register will be getting this particular values. Okay, and then while, so this particular statement, it will keep the status of this particular LED as it is. If it is on, it will be in on condition till my TF will be 1. So as soon as this TF becomes 1, it will come out of the loop. Then you see I am giving TR0 as 0, TR0 as 0. That means I'm asking my microcontroller to stop this particular operation, and I'm again making TF0 as 0. So you see what is going to happen. Again, once this particular function is completed, it will go to this particular part, that is LED negation of LED. So now in earlier case, my LED was in on condition. Now it will be in off condition. And again, it will call the delay function. It will assign this particular values over there. Then again, my timer 0, I mean, will be monitored, okay, by this particular bit. Okay, so the value was 56320. So it will be incrementing up till 65536. Okay, and after that, like once this timer 0 reaches this particular value, my TF would be 1. Again, it will come out of the loop, and all of the things will happen again and again. So this is how we are going to generate a delay of 10 millisecond. Okay, so now let's see on the Proteus software. Let me erase all of the thing, and now let me go to the Proteus software. First of all, let me burn this particular code. You see, we are actually burning the hex file of this particular code. So this is my hex file. I'm just going to burn it. But before that, let me just compile it. Although I had to compile it, so we just compile it. It has created. It should create certain hex file. But before that, you see we are getting 0 errors and 0 warnings. Okay, and then I need to burn this particular code. So what exactly is going to happen is that we will be getting certain hex file. So that particular hex file we are going to burn in the controller. You see the timing 1.5 over here as well 1.5. Just now we updated the code. So that's why it is showing the same time. Open and then click on OK. Now let me just run this particular circuit. All right. So you just have a look over here. We are getting a square wave signal, right? We are getting a square wave, exact square wave signal. Okay. Is this part visible? Is my screen visible?
Yes, sir. Yes, sir.
Okay. So now you just have a look over here. You just need to click on cursor, and let me just click somewhere over here. 0 seconds. Now let me click somewhere over here. So basically, to calculate the time delay, we need to see, or we need to check what exactly is the time delay. Yeah, you see over here these two times. Let me take the pen. Yeah, you see, is this part visible? 0 seconds, 0 seconds, and this is 10 millisecond, 10 millisecond. And if you calculate the difference, it is 10 milliseconds only. So the difference is 10 milliseconds. So at 0 second, the signal was transitioning from 1 to 0, and from at around 10 millisecond, the signal is transitioning from 0 to 1, right? So that means what? Between each and every 0 to 1 pulse, we are getting a delay of 10 millisecond. Okay, I hope this part is clear.
Yes, sir.
Okay, great. Is there any sort of doubts? Anyone? Any doubts up till here? Any doubts? Anyone? Let me check the chat as well. No doubts up till here. Shall we proceed further? Let me go to the next numerical. Okay, so I want input from you all guys. So this time again we are creating a delay of 60 millisecond. Okay, using timer 0 mode 1. Okay, so please someone acknowledge me to create a delay of 60 millisecond. So again, what we are doing, we are actually dividing the desired time delay with the this particular time, that is 1.085 microsecond. So I'll just quickly do it. Someone please calculate this particular values for me. I'll request you to please calculate this particular values for me. See, the desired time delay is 60 milliseconds. 60 millisecond divided by 1.085 microsecond. Microsecond. Please calculate this for me. Can someone please calculate this particular, uh, uh, perform this particular calculation for me, and please give me the accurate value. Then I will move to the second step. That means whatever the value that I will get, I'll just subtract it with that particular value, that is 65536. 65536 minus of whatever value we'll get, that is x, right? And whatever the answer we'll get, that will be y. And then we need to convert this particular y into hexadecimal value. Please calculate this particular values, guys. 55299. Okay, 55299. This is 55299, right? Then perform this one. Y is 10237. 10237, great. And then we have this, so we need to convert it to hexadecimal. So let's do it over here only. What is my Y, by the way? 10237. Okay, so 10237, let me convert it to hex. It is 27FD. 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 Just cross check it. Just cross check it. Yes, 27FD. Okay, so it is fine. Great. So now let's see how exactly we are going to perform over here. So you see the entire program will remain as it is. What we are going to do, we are just going to make changes over here. Just a second. Okay. So let me just show it to you over here as well, that we are going to put this FD in TL0. So in TL0 we will be having FD, and in TH0 we will be having 27. Okay, so let's put this particular values over here. So TL0 FD. Okay, so in TL0 I'll put FD, and in TH0 I'm going to put what, this 27. Yeah, 27. Just a second. 27, right? So now let me just compile it. You see, zero errors and zero warnings. Now we are going to burn this particular code. So whenever you are trying to build this particular program, each and every time this particular code or the hex file which I shown to you, it gets updated. Okay, so that values has updated in the timer 0 register. Okay, so now let's run this particular thing as well on the onto the Proteus software as well. So where it is, yeah. So now let me again double click on it, and now you see 111, and you see 112 over here. So that means just now we had updated this particular code, and that means what, our hex file is also updated, right? So let me just click on it, click on open, uh, then click on OK. Now let me just run this particular simulation. Oops. Let me just pause it. Yeah. Now we'll try to calculate the delay over here. You see somewhere over here at this particular point, it is 0 second, and you see it is around 60 milliseconds. Yeah. Are these values visible? Please someone acknowledge. You see this is 0 second, and this is 60 millisecond. 60 millisecond. Are these values visible, guys? Please acknowledge. Hello.
Yes, sir. Yes, sir.
Okay. So are you able to understand that how exactly we are creating a delay, or basically a delay of 60 milliseconds with the help of timers which are available in 8051 microcontroller. Okay. So now let me stop it and let me erase this. Okay. So let me just save it. And now I would like you all guys to perform this particular operation, that is generate a delay of 1 second. Okay. Generate a delay of 1 second by using timer 0 and mode 1 only. You will get certain error. Okay. Please put these values over here, and then we'll try to deduce something out of it. I'll request you to please generate a delay of 1 second. Again, I'm repeating. Generate a delay of 1 second using timer 0 mode 1. Generate a delay of 1 second using timer 0 mode 1. And please update the values. I'll just start it for you all guys. Our intention is to generate a delay of 1 second. So 1 sec, so sorry, not yeah, 1 sec divided by 1.085 microsecond, right? And then whatever value you will get, you need to subtract it with this one. Okay. Rough idea I'm giving. Can someone tell me the values? Just perform this particular calculation. 1 second divided by this, that is 1.085 microsecond, and then we have 65536 minus of this. Just perform this. 921658. Okay, this is 921658, and then perform this one 921658. Perform this particular calculation. What is the answer that you are getting? Yes, minus 856122, minus of 856122, something like that. But you see, this particular number, you know, it is greater than 16 bits. If we try to convert its hexadecimal equivalent, so it will be greater than 16 bits, and on top of that, this is a negative value. So with this, what we can conclude is that 8051, I mean the timer 0 and timer 1, if we are using it for timer operation, so at max it can create a delay of 65 millisecond only. This is the maximum delay that it can create, because you see, this is the maximum value that is available, that is 65,536. Okay, so if it is 65,000, then also you see we can somewhat create a delay of around 65 millisecond. Okay, but we cannot create a delay of 67 seconds, 68 second, or 70, 80 milliseconds, or maybe 1 second, 1 minute. So that is the drawback that we are getting with this. So does anyone have any sort of idea how to proceed further in this particular scenario? See, we are getting certain error. We need to tackle that. So for that, we need to apply certain logic. Anyone can guess that what we can do with this? Any idea? Any idea? Any idea on how to proceed further? Guys, please acknowledge, guys. Any idea? Okay, so I'll only reveal this. See, now we have a drawback that we cannot create a delay greater than 65 millisecond. But what we can do is that we can actually create a delay of 10 milliseconds. So we can actually use this particular 10 millisecond over here. So how? Just have a look over here. See, we can use n cycle of 10 millisecond to create a delay of 1 second. That means n is equivalent to 1 second is nothing but 1000 millisecond, right? So you see 1000 millisecond divided by 10 millisecond. So the answer we'll get is 100. So what we need to do is that we need to create a delay of 10 millisecond inside the for loop. So we will use for loop, and inside that particular for loop, we are going to create a delay of 10 millisecond. Getting this point? Is this part clear? Is this part clear? Okay, great. So now let me again go to the kill software. Let me start this, and Okay, so just let me know if this particular code it is visible to you all guys. Just let me know. Is it visible?
Sir.
Yes, sir.
Okay. So you see over here, everything is same. Just the thing is that we had created two more function. Okay, that is 1 second and 10 millisecond. You see even our entire logic is same. Okay, and then you see over here, uh, I, I had used for loop over here. For I is equal to 0, I is less than equals to 100. Okay, then we are calling 10 millisecond of delay. So it will go in this particular function, and over here had already assigned this particular values. If you want, you can just cross check it over here. You see TL000 TH0 DC, TL000 TH0 DC, right? It will go, it will start the timing operation as my TR1 is 1, right? All of these particular values will be called over here where it is, yeah. And then it will monitor for around um, uh, 10 millisecond. That means up till my timer 0 reaches this value, that is 65,536, 65,536, right? And it will iterate, this particular loop will iterate for 100 times. So you just have a look over here, 10, this is the delay which I had created, 10 millisecond into 100, and by the way this is in millisecond, right? So 100 is present in the in the for loop, and this is the delay which I had created over here. So that is 1000 millisecond, which is equivalent to what? Which is equivalent to 1 sec, right? I hope this part is clear, and this is how we are going to create the logic for it. Is this part clear? Is this part clear? Because see, are you able to understand that why exactly we did we actually created a delay of 10 millisecond, then I actually give you a delay of 60 millisecond, and then we are actually seeing 1 second. Are you able to understand the logic? Because see, I just wanted to show you that it cannot go beyond 65 milliseconds, so we are using for loop, right? So how come we are going to create a delay of 1 minute? So obviously for that we are going to use 60 millisecond, and for that again we are going to do same thing. That is, let me add one more slide over here only. I'll just explain that particular part as well. So see, we have 60 milliseconds, we can create a delay of 60 millisecond. So we need n such cycle of 60 millisecond to create a delay of 1 minute, which is equivalent to 60 second, right? So you see n is equivalent to 60 second divided by 60 millisecond, which is 60 into 10 raised to minus of 3, right? Seconds. So 60 and 60 will get cancelled. We have 1000 as the answer. So in that case, our n should be 1000, right? So whatever the main code that we will be focusing upon for the heartbeat sensor, so over there we are again going to create a for loop as we had created in this particular scenario where it is, yeah. But over there we are going to keep the value as 1000, and over there we are going to keep the delay as around 60 millisecond. And that's the reason that I was focusing upon this particular concept. I hope you all guys understood it, right? I hope you all guys understood this particular concept. Is everything clear up till here?
Yes, sir.
Okay, great. So now what we'll do, we'll again take a break of 2 minutes, and then we'll see the LCD, how exactly LCD we are going to interface with 8051. Okay. So now the next topic will be LCD. So till then, I'll request you to uh, just follow me on Instagram. You can just scan this particular image. Okay. We'll just have a break of 2 minutes, and after that, we will start this session. And after like in that particular session, we'll see how to interface LCD and how to display your name or certain characters onto the LCD. Okay, is this clear? So what I'll do, I'll just take a break of 2 minutes, and then we'll again join back. So till then, you just image. So shall we start the session, guys?
Okay, sir.
Okay. Okay, so now we are going to interface LCD with 8051 and we are going to display certain characters. So for that, we first need to understand the pinouts of LCD. So you see over here, LCD in total, it has 16 different pins. So I had just taken a screenshot from the Proteus, and in Proteus, they had not shown the other two pins, that is LED plus and LED minus. But you see over here, these are the 14 major important pins which are present inside the LCD, that is VSS, VDD, VEE, RS, RW enable, and these are the 7 data pins. Okay. So now we are going to understand the functions of each and every pin step by step. Let me proceed further. And as usual, I had taken the screenshot of my notes. Okay. So you see what we'll do, we will try to read each and every point, and after that we'll try to understand each and everything in detailed way. So you see this is 16 into 2 LCD 8-bit mode. I mean, it can be used in 8-bit and 4-bit mode. So first of all, we'll try to clear this. What is 16 into 2? So you just have a look over here. There are how many blocks? 1, 2, 3, up till we have around 16 blocks. So there are 16 block. Okay. And we have 2 rows, right? We have 2 rows. So 16 into 2 is how much? 32. 16 into 2 is 32, right? So you see the total number of characters that we can display is around 32. So this is what I had mentioned. In total, we can display around 32 characters because we have 16 into 2. Okay. And what is 8-bit? 8 bits means we can use 8 total data lines, or we can only use 4 data lines to provide data or to display the data or to give commands to this particular LCD. Okay. Now let's move to the next line. That is, each block is of 5 into 7 matrix where we can display a single character. So you just have a look over here. Each of this particular block has around, you see, 5 into 7. So these are, you see, 7 uh, columns. Sorry, 5 columns. You see, 1, 2, 3, 4, and 5. So these are the 5 columns, and there are total 7 such rows over here. So each block is of 5 into 7. That is 5 columns and 7 rows. And in each block, we can only represent one character. That means what? Let's suppose if this is the block, so we can only represent A over here, or we can represent B or C. We cannot represent, A, B, something like this. Okay, this is not done in within a single block. We can either represent A, B, C. I mean A or B or C in one block, or 1, 2, 3. It depends upon the character which we want to represent. Okay, is this part clear? So now let me proceed further. But before that, let me just ask, is this part clear or not?
Yes, sir.
Okay. So now let's proceed further. And now we will try to understand the function of each and every pin that are available over here. So starting with the very first pin, that is VSS. Starting with the very first pin, that is VSS. So we need to connect this particular pin to ground. So I'll just connect this particular pin to ground. So as usual, if you had work in electronics, so you take any component. So a component needs to be connected to the positive and the negative side, right? So on the similar note, LCD needs to be connected to the positive supply and the negative supply, right? So this is what these two pins are doing. VSS, we are connecting it to ground. Then we need to connect VDD to the supply voltage. That means we need to connect it to plus 5 volts. See this VDD, we need to connect it to plus 5 volts. And then we have VEE, that is pin number 3. So you see over here, it is used for LCD contrast. So we had completed this particular point. Now what is LCD contrast? So I hope that you might have used your smartphones maybe in presence of sunlight and in presence of like in certain darker room as well. So have you noticed this particular point that whenever you are using your smartphone in presence of sunlight, so the brightness of your phone, it increases, right? On contrary, if you are using your smartphone in absence of sunlight, maybe inside your room, if that particular room is quite darker, so you see the brightness of your smartphone decreases, right? So same thing is happening over here. Just the thing is that over here we are doing it manually. We need to connect potentiometer over here. Okay, we need to connect potentiometer to make sure that the brightness of the LCD, we are able to change that. Okay, but since we are doing simulation, so in simulation it's fine even if you uh, connect this particular pin directly to 5 volts. Okay, but in reality it doesn't work because I had seen that. So in reality you need to connect one potentiometer over here. Okay, but as far as simulation is concerned, it's fine even if you connect this particular pin to 5 volts. Okay, now these are the three major important pins, that is RS, RW and enable. So you just have a look over here, the RS pin, that is register select. Register select pin. If RS is 0, we are going to send a command. And if RS is 1, we are going to send data. So let me just elaborate this. Let me just show it to you. So this is my RS pin. I think I just got one. Let me check. No. Okay, so if my RS is 0, let me write it in this way. Yeah, if my RS, if it is 0, so that means we are sending command, and if my RS is 1, that means we are sending data. So over here I'll send command if my RS pin is, sorry, if my RS pin is 0, and if it is 1, we will send a data. We will send a data through that. Okay. And basically, who's going to control this particular pin? So basically this particular pin is controlled by your microcontroller. So this particular pin, we are going to connect it to the microcontroller. Okay. Getting this point? Now comes the next pin, that is read and write pin. So we'll make this particular pin as 0. That means we will just ground this particular pin, and you can read the reason for that. You just have a look over here. If RW is equivalent to 0, we will write, and if RW is equivalent to 1, we will read. Now we are using LCD for writing operation only. We are not using LCD for reading operation. So we will prefer it to connect it to ground. So we'll connect it to ground. We will show it to you. So I'll connect this particular pin to ground, and then we have enable pin. So you just have a look over here. We have enable pin. So if my enable pin, if it is getting this kind of signal, that is 120, so it will write the command or data onto the LCD. I will come to this particular point. Don't worry. As of now, just focus upon the things that I'm writing onto this particular board. Okay. So let me just write over here that this particular pin, we use certain different color. Yeah, I'm going to connect this particular pin as well to the microcontroller. Okay. So whenever this particular pin gets 1 to 0, that means high to low pulse, then the microcontroller will be getting the commands or data, and these are basically the data lines through which we are going to send the data or commands. So these are my 8-bit data lines. So we are going to send data. So this is my data pins through which we are going to send command or data. Send commands or data. Okay. So I'll just explain you. We are going to connect this to the power supplies, respective power supplies, that is ground and positive. We are going to connect this particular pin, that is RS, to the microcontroller, which, like, if microcontroller sends 0, that means our microcontroller is sending command to this particular LCD, and that particular command would be sent by this particular pins. Okay. And for sending that, your enable pin, it should move from 1 to 0. Okay. I hope this is clear. Everything is clear up till here, guys. Everything is clear.
Yes, sir. Yes, sir.
Okay, great. So now what I'll do, I'll just open the kill software to show you one code. Just a second. Just let me know if this is visible to you, if this particular entire circuit is visible to you all guys. Is this part visible?
Yes, sir.
Now let me just run this particular circuit and let me just show you. So you see, I want to display one character onto this particular LCD, and that is character A. You can take any character A, B, C, D, but what I want is that I just want to display one character A. So how we are going to write programming logic for that? So for that, let me go onto the kill software. Yeah, this is the program that I was talking about. So you see, again, we are going with the same thing, that is header file. Then we have command and data. I will elaborate this particular function, don't worry. And then I'll create a delay function, and you see RS pin is connected to pin number 1 of port 2, and enable pin, it is connected to pin number 2 of port 2. So you just have a look over here. My RS pin, it is connected to pin number 1 of port 2, and over here this particular enable pin, I'm connecting it to pin number 2 of port 2. Okay, so this is what I had mentioned over here. Now I had created a delay function which will create a delay. I will come to this particular point, that why exactly we need to create this particular delay function. Now from here our program starts, and as I had mentioned that if you want to declare certain port as the output port, so for that you need to assign this particular value, that is 0x00, which will ensure that whatever this system that we had connected at that particular port, it will act as the output port. And you can clearly see where it is. Just a second, that my port 3 is my output port because I had connected LCD over here. Okay, so now again let me go over here, and you see LCD command 0x38. Okay, so now we need to understand this particular concept, what exactly is happening over here. So for that, again, let me go onto the blackboard. So yeah, so these are the functions which we need to, sorry, these are the commands which we need to see, or which we need to give to the LCD to operate it. So I had given this particular function, that is 0x38. That means function set 8-bit 2 line 5 into 7 dots. What does that means? That means, you see, I will be using all the 8 data lines, right? I'll be using all the 8 data lines, and I will be using all of these all of these two rows, and I want that each of these particular blocks which are present inside this particular rows, it should be enabled. So basically it is used to enable the 8 data lines, two rows, and then 5 to 7 dots. All the blocks, all the 2 lines, and all the 8 bits all the 8 bits of data lines, you see. So it will enable these pins, that is D0 to D7. It will also enable these 2 rows, and then you see it will also enable the blocks 5 to 7 dots, 5 to 7 5 to 7 cross matrix, right? So it will enable all of them. Okay, so just have a look over here how exactly it will function. Let me just zoom this. So it will call this particular function, that is LCD CMD. Okay, and now what exactly I had done over here is that I had declared one variable, that is L. Okay, so now this L will get this particular value as 0x38. Okay, now RS is 0, and as I had mentioned that if my RS is 0, so if you could remember, let me just show it to you. Yeah, if my RS is 0, that means I am sending certain command, right? So if you make this bit as 0, so the LCD will come to know that I'm getting certain command from the microcontroller, right? So for that very purpose, I had written RS as 0. Then we have enable 1, and then we have delay for around 100 microsecond, and then we have 0. So before that, let me just take the decimal of 38. Sorry, let me convert from hexadecimal to binary, and hexadecimal of 38. Let me convert it to binary. So this is the value, that is 001100. So for that, let me just go over here, 00111100. Okay. So you see my L will get this particular value 0x38, that is 001111 and 000, right? Something like that. So this particular value will be assigned to port 3. You see this particular values, port 3 will get this particular entire value, that is 001111 and 000. Okay, and then I'm making RS pin as 0. Okay, and then we have enable as 1, and then we have delay of around 100 microsecond, and then enable as 0. So what exactly will happen is that, let me now go to the uh, Proteus software. Now let me erase all of this particular thing. I'll just keep this particular part. See, my port 3 will have this particular values, that is 0 0 triple 1. Okay, triple 1, and then 0, something like this, triple 0, right? 2 3. So port 3 will hold this particular value. My port 3 will hold this particular value. Okay, and RS is 0, right? RS, where is RS? RS is any which way 0. Now, as my enable pin goes from 1 to 0, that means when it will make transition from 1 to 0, so at that particular time all of this particular data will be transferred to this particular LCD, right? And since my RS is 0, so this particular LCD will come to know that, okay, so I'm receiving certain command. So inbuilt, this entire table which I just shown to you, entire table of commands, it is present inside this particular LCD, and then it will set all the bits and all of these things, right? That is, we need to set 2 bits and then all of those things as I had mentioned. Is this part clear? Is this part clear, guys? Just reply. Is this part clear? Is this part clear? Please reply, guys. Hello, am I audible?
Yes, sir.
So you see, I done same thing over here. That is LCD command 0x0c, LCD command 0x80. 0x0c, that means you see over here, I'm making display on and cursor off, and then 80, I'm forcing the cursor to start from the first row, first column. Okay, that means I'm asking the LCD to display the character, that is in our case that is A, from somewhere over here, from the very first block. So I should see A somewhere over here. Okay, so now let me erase this, and then if you look over here, this is my LCD data A. So you see, even the data will be given to the LCD in the same format, that is port 3 will receive the binary equivalent of A, and then RS is 1. So this time my RS is 1, which will ensure that the LCD is getting data. Okay, and then when my enable pin, it goes from 1 to 0, so then we are able to receive that particular data onto the LCD. I hope this is clear. This entire code is clear to you all, guys. So now what I'll do, I'll just build it in front of you, and then I'll just update this particular code or the hex file over here. Okay, let me just update this. Now let me just run it, and you see, you will get a single letter A over here, right? Now let's suppose if I want to display some another character over here, maybe A, B, C, D, F, G, any character. Okay, so for that I will need to check the commands. So let me go over here, and now what I will do is that, hello.
Yeah, yes. Hello, sorry.
Yes, sir.
Can we summarize the project?
Okay,
Because
okay,
there
no
are
issues.
some other schedules.
Okay,
Uh,
okay, no issues, no issues.
Sorry to interrupt you, but there is some confusion.
Okay, okay, no issues, no issues.
So if you can skip one more character and summarize the entire Harbit concept, that
Yeah, yeah,
would be
sure,
benefit.
sure. Yeah, sure, sure.
And sorry again for
No,
interrupting.
no issues, no issues, no issues. So is this screen visible now?
Yes, sir. It is visible.
Okay. So now let me explain you the code very shortly. The heartbeat monitoring system. So you see, I have used the timer function, the delay as I had mentioned, and I had included one more function that is hex to ASCII function. But before that, let me go on to the void main function. So I had connected, the output to the port 2, and this is what I had mentioned over here. You see, at the port 2, I'm connecting the output, that is LCD, and then here I'm giving the same commands to my LCD, and after that, I need to display this particular string, that is bits per minute, and it will go into that particular loop, and it will actually monitor the position of that particular character, that is b is present at 0th position, 1, 2, and so on, and then it will display this particular entire string. And after that, as I had mentioned, that we'll be using tmod register, and in that we will use timer 0 for timing operation and timer 1 for counting operation, as I had mentioned over here. And then we'll start this particular operation, and then this is the main function over here, hex to ASCII. So I'll just like to show you the working of this particular project. Let me just run it, and yeah, you see over here bits per minute. Is it visible? Just acknowledge, guys. Is it visible? Hello? Rasik, Kedar, is it visible? Okay.
Yes,
So you
sir.
see,
Yes, sir.
okay. You see the bits are updating, and you see I'm getting low to high pulse from Vout, this particular sensor, and it is keep on it will keep on incrementing, right? For around 1 minute, we'll see, we'll monitor it. We'll just see the number of bits that we'll get within a minute. Yeah, you see now it is almost constant, that is 29. So basically, we are getting around 29 bits within a minute. So this is how I had programmed this particular controller, and this particular thing, that is 0 to 9, it is visible because of this particular function, that is hex to ASCII. Okay. Um, if I may get some more time onto this, maybe in some another session, I'll elaborate this. Or don't worry, I had made my course where I had explained each and every part in detail way, so I'll share it with you all guys. Okay. So, sir, should we wind up? I just shown the working. Hello. Hello. Hello, sir. Am I audible? Hello.
Yes, sir. Neelam here.
Hello, Nila ma'am. Good afternoon. How are you, by the way? Hello.
Hello. Yes, sir. You can hear me now?
Yeah, I can hear you. Hear you.
Yeah. See, Hari sir just now went outside. He had some call from higher authority.
Okay. No issues.
Yes,
Sorry,
yes, yes,
I'm
yes.
there.
What?
Okay.
Hello.
No,
Sorry,
he's
I'm
there.
connected with my
Hi,
mobile.
Hari,
Just came
Hari sir.
out.
Okay.
Uh,
So,
sorry to
sir,
in
can we
between.
wind up now? Like, I had
Yes,
made one course as well. So, the remaining part, I had explained that in detail way in that particular course. So these guys can actually go through it once.
yes, sure. I'll share the link with them. And
Okay. No issues.
thank you very much for your time. And It was a wonderful session where you explained the entire system design was awesome.
Yeah, thank you. Thank you
Only
very much, sir.
we were running out of the time because
Yeah. Hmm.
people are having
Yeah,
other
no, sir. This is what
activities.
mostly happens with me. Like, when I actually try to explain the concept, I try to go in that detail way. Like, I try to elaborate it in much more detailed way.
No,
But
that's a good way.
from next
Keep
time
it
onwards, I'll try to keep it as short as possible. But it
no
doesn't
need
happen from my side.
no need to change. This is the best way. Even I go that way, so it's fine. It happens. At times we need to work extra, but it's okay. That's good for everyone. Uh,
Yeah, yeah.
so thank you very much. And I
Thank
was
you, sir.
hoping to meet you, but next time definitely we'll have a offline session.
Yeah,
Next
sure, sure.
semester, thesis student will be in semester 6, so they'll have some processor again, DSP or some image processing. So we'll have a
Okay,
offline session for them next semester.
okay, okay. So
We'll
no,
plan
sir,
that.
not DSP because I'm not that good in it.
No, no,
I myself had left
process.
that particular subject for option.
No. DSP processors I'm talking about, not
Okay,
the
okay, okay.
processing.
Okay, I got the idea. Okay, sure,
Yes.
sir.
Yeah.
And sir, I
So
will
thank
just give you a link of feedback form. Just please ask those students to fill the feedback form. It will be helpful
you.
for me. And I'll
Yes.
recommend you to fill that particular form as well.
Yes, please send the feedback form and the link of your all social media handles also. I'll forward
Okay,
it to
sure, sir.
them. Okay, it will be beneficial for them. All the social media handles along with this feedback form.
Okay, sure, sir.
Yes. Thank you very much, Sorit. Other
Thank you,
student.
sir. Thank you for
Yes.
inviting me.
Are Nana, you deserve it.
Thank you, sir.
Yes,
So,
student will sign out and join your respective classes as per the schedule. Thank you, Sorit. Nilam, ma'am. Thank you,
okay,
everyone.
thank you, sir.